Welcome back, guys, to Remote Explorations. This is me, Sinyan. Uh, a whole lot of days I'm bringing back. Continuing my crash course videos for ISI and CMI entrance examinations. I had my college examinations, some functions too, and then the work at Siastra 2, which I was telling you all about. So, without further ado, let's get started. Sequences and series. We started sequences and series. For all those who haven't watched my first video on sequence series, let me just give a small revision for you. So this was my sequences and series where I had first done a bit of number theory which was left, and then we had started with progressions, AP, GP, and HP. Just a second. Yeah. So we had started with AP, A1, A2, A3, and A all specific different numbers which are in a proper series and which are interlinked with one another, where my A1 is the first term, N is my number of terms, and D is my common difference. So these are the usual notations on how we denote problems while solving for arithmetic progressions. Then came my common difference is basically your second term minus first term. So this is how we take terms. So D is my difference, which is the only constant thing between the two terms and which link the two terms and also the series. So A plus D, A plus 2D, A plus 3D dot all the way till A plus N minus 1 into D. So that is known as my Tn or the nth term. Now coming up to my summations, I had shown you how to derive the summation, which is basically n by 2 into 2A plus N minus 1 into T. That is my summation. Or you could be writing it as n by 2 into A plus Tn or n by 2 into A plus L, where my L denotes the last term. Summarizing, these two are the formulas. Now, taking terms in, there are various questions in which we have to hold and let take terms something in order to calculate our missing statement or the problem. So when we are taking three different terms and we do not know both the first term and the common difference, but some other information is given, like as the summation of the three terms or the summation of the four terms and so on. So we can take my three terms to be A minus D, A plus D, as you are seeing it here. My common difference is D. Similarly, when taking four terms in AP, my common difference has to be 2D. You'll see it very well, A minus 3D, A minus D, so A minus D minus of A minus 3D, that is basically 3D minus D, that is your 2D. Similarly for five terms, then we did some questions. I told you about arithmetic mean. This was all we had done in our first lecture. Now we'll be starting with geometric progression most probably. I would like to do one or two questions. One very interesting question, big one, but it is interesting. Let's do it. It's based on AP. It might hang a little. I'm telling it from the beginning itself. My screen might be frozen, but don't worry, the video would be cool. So we are given basically what we have said. We are given two sets of numbers consisting of three terms in AP. So we have two different sets, which each set is an AP consisting of three terms. And the sum of each set is 15. My sum of each set is 15. The common difference on the first term, we are given that by CD, I am denoting common difference by CD. CD of first set is greater than the CD of second set by 1 and product of the first set to the product of the second set. Product of the first set to the. It is basically talking about the ratio, that ratio of the product of the first set to the product of the second set is 7 by 8. We need to find the numbers of both the sets. Take 2 minutes and think. So I'm just gonna be concising it and explaining the question to you. So we are given two different sets of numbers, of which each set consists of 3 numbers and all of them are in AP. Both are two different sets of APs. Sum of each set is 15 and the common difference of the first set is greater than the common difference of the second set by 1. And the product of the first set of the numbers to the product of the second set is 7 by 8. The ratio of the product of the first set of numbers to the ratio of the product of the second set of numbers is 7 by 8. So we need to find the numbers. Excuse me. Take 2 minutes to think. Yeah. I guess you all have given it a thought. With the yellow. So we are given two sets of numbers. Let my first set be, as I had said, when you are going to express 3 numbers in AP, what are we going to take? A minus D, A plus D. So my first set is basically, let me take my first one to be A1 and common difference to be D1. So my series is basically A1 minus D1, A1 and A1 plus D1. My first set. Then my second set is basically A2 minus D2, comma A2, comma A2 plus D2. Sum of each set is going to be 15. When you're going to be summing up all the 3 terms, what are we getting? I am getting my 3A1 to be 15, and here I am getting my 3A2 to be 15. A1 is going to be 5, and my A2 is going to be 5. So we have got one information, that is my first terms of both the series I have got. The common difference of first set is greater than the common difference of second set by 1. So my common difference of first set is D1 and my common difference of second set is D2. Also, D1 minus D2 is given out to be 1. This is my one equation. And product of the first set. So what is going to be my product? The product would be basically your A1 into A1 minus D1 into A1 plus D1 pi, just keeping brackets up here. These dots mean multiplication, okay? Pi a2 into a2 minus d2 into a2 plus d2. This is basically your 7 by 8. Cool. Now what do we know? My a1 and a2 both are same. Since a1 is also 5 and a2 is also 5, so I cut my a1 and a2. What are we left here with? We simply have, so this is what I can say, my a minus b into a plus b, a minus b into a plus b. Basically, this is the formula of a square minus b square. So a1 square minus d1 square divided by a2 square minus d2 square, that is equal to 7 by 8. My a1 and a2 both are 5, so 5 square is 25. That means my 25 minus d1 square by 25 minus d2 square is basically your 7 by 8. I'm going to cross multiply them. So I'm going to multiply 8 this side and 7 this side. So 8, 25 into 8, that gives me my 200 minus 8 at d1 square equals my 175 minus 72 square. Now, if I'm going to bring that to that side, so what I'm going to do is 8 d1 square minus 7 d2 square is basically your 25. Now this is my another equation. But d1 minus d2 is 1 and my 8 d1 square minus 7 d2 square is 25. Now we need to solve them. Therefore, to solve, think how can we solve them. I'm going to write the equations up here. So one equation is basically your 8 d1 square minus 7 d2 square equals 25. And my next equation is the previous equation, I should say, d1 minus d2 is 1. So my d1 minus d2 is 1. Now time to solve them. How do we solve it? Okay, so let's substitute. In place of my d2, I am gonna put d1 minus 1. So 8 d1 square minus 7 into d1 minus 1's whole square, that gives me 25. It's basically method of substitution while solving two quadratic equations. So if I'm gonna break this whole square, so that gives me 7 d1 square plus, or probably minus 7. Yes, guys. Just a second. So 8 d1 square minus 7 d1 square minus 7. This is going to be plus 14 d1. That gives me 25. How? Now if I'm going to take my minus 7 to be common from here, so it gives me my d1 square minus 2 d1 plus 1, which is my d1 minus 1's whole square. So this basically gives me d1 square plus 14 d1 minus 7 equals 25. So then I can be getting my d1 square plus 14d1 minus 32 equals to 0. So time to middle factorize it. So my d1 square, I can be writing it to be my plus 16d1 minus 2d1 minus 32 equals 0. Then if I take my d1 to be common here, I am getting it to be d1 plus 16. If I take my minus 2 to be common, then I am getting my d1 plus 16 equals 0. So ultimately what I'm getting is d1 plus 16 into d1 minus 2. That gives me 0. This is 0. Okay, this is not 6. So here I can get my d1 to be 2 and d1 to be minus 16. So we are getting my d1. Then I will obviously be getting my d2 and hence the answer. So from here it's your responsibility to solve. I have solved the main crux. So these are how tough questions can be made. This is not tough. This is a bit lengthy. But yes, in MCQs, these are categorized as tough since you might be making some calculation error and that will be destroying the full problem. So do keep in mind to read the question properly. This is a tip for all aspirants who have exams this year, who will be having exams next year. Read the question properly once, twice, thrice. Just try reading it and understand the crux. Try forming the equations, and while solving them, do just have complete focus on that and try not to do any calculation error. And went away. I will just be closing the doors and coming. So we are done with AP here. Next, what we are going to start is our GP, or the geometric progressions. The next discussion topic is geometric progressions, or simply GP. Okay, so here how my terms will be given. Like in AP, what was given? A plus D, A plus 2D, dot 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 dot. Here how will be given A, AR, AR square, AR cube. How far will it go? Like in series, the understanding of the nth term is too easy. Like this series going like this. So what can we say? In my third term, I'm getting 2 as the power of r. In my fourth term, I'm getting 3 as the power of r. So basically in n, I will be getting n minus 1 to be the power of r, and my a remains constant. So ultimately, my nth term of the GP series becomes ar to the power n minus 1. This is my Tn. Got it, guys? Sorry for my video not being correlated with my audio. Something might come faster and the other one slower. Do go over with it. I am trying to fix out some solution for this. Now coming up to this summation. A plus AR plus AR square plus AR cube plus dot dot dot. This is, just remember this value. This is basically your A into 1 minus r to the power n by 1 minus r. Now we have two different formulae for this. So this is only when my r is less than 1, or if my r is greater than 1, that is my common ratio. My r is called as the common ratio here. There it was my common difference. Common difference was basically your second term minus first term. And here my common ratio would be basically your second term by first term, which is my r. So this is my common ratio. Or a into r to the power n minus 1 by r minus 1, that is r greater than 1. Next up is my infinity series. One more part comes in my geometric progression, that is my infinity series, which is basically when the terms go up to infinity. For an example, like this. A plus AR plus AR square plus AR cube plus all the way till infinity. Now, there's no nth term for this, okay? Since my nth term would be going to be infinity. But when my r is less than 1, my general cases would be following my r to be less than 1. Like all the cases I solve for examples, for some sort of proof, unless and until it is mentioned in the question, you are gonna be taking r to be less than 1 and gonna be using the first formula. So when my r is less than 1, I need my summation. So my summations formula is basically a into 1 minus r to the power n by 1 minus r. My n is infinity. Now what we know, r to the power n is greater than 1 r for r greater than 1, and my r to the power n is less than 1 for r less than 1. So here my r is less than 1. So this thing is ultimately going to be very, very less than 1. So it is going to be close to 0, like approximately equal to 0, but not exactly equal to 0. So ultimately my this term vanishes and my this comes out to be a by 1 minus r. This is my summation of infinity series. So if I'm gonna be summarizing the formulae, summarizing the formulae, my number one is Tn or my nth term, which is basically AR to the power n minus 1. Then comes up my Sn, which is basically A into R, 1 minus R to the power n by 1 minus R, or A into R to the power n minus 1. Sorry for this mishap. A into R to the power n minus 1 by R minus 1. I mean, infinity series S infinity is basically A by 1 minus R. Now, there was a thing in AP where I was taking up terms, and I showed you the last question by taking at an example here also. There, what I was doing, my A minus D, A plus D, it was for 3 terms. Here it is going to be A by R, AR for 3 terms. For 4 terms, with my common ratio is here R. But for my 4 terms, it is going to be A by R cube, A by R, AR, and AR cube. This is for my 4 terms. Now you might be thinking, what is my common ratio here? So divide my second term by the first term. A by R cube, that gives me R square. Similarly, AR by R, that gives also me R square. So this is how you are going to be taking up terms. One very common question or quick question to just show you how to take terms. We need to find 3 terms in GP. Whose sum is 19 and product is 216. It for 1 to 2 minutes, then I will solve it again. Yeah. So let me solve it. So what do we have here? We have my three terms in GP. So as I had said, I'm taking my three terms, my A by R, A and AR. They are in GP. My product is 216. Whenever you are in GP, just try to focus on the product part first. And when in AP, try to focus on the sum part first. That is a basic general suggestion. So my product is given to be 216. So if I'm going to be doing my product for all these three terms, that will be A cube is 216. Then my A is basically 6. And we are given here that is my summation is 19. A by R plus A plus AR is given to be 19. So if I'm going to take my A to be common, so R plus 1 by R is going to be 19. My A is 6. So R plus 1 by R plus 1 is basically 19 by 6. If I'm going to take my 1 to that side and subtract it, what will I be left with? R plus 1 by R is basically your 13 by 19. Now this is a quadratic equation. So it is basically R square plus 1 equals 13R by 19. So then it might be coming as 19R square minus 13R plus 19 comes out to be my 1. So again we are left with middle term factorization. So my 19 into 19 is basically a 361. So we will be factorizing my 361 up here. So one factor of 361, anyone? So from here it's all yours. A critical value of R will come. You need to solve it and get the answer. Now let's see what more problems we have. Concept is only this much, nothing more. One homework for you. Let's try to solve it. So what is my homework? My homework is let A1, A2, A3 dot be a sequence such that A1 equals to and an minus of an minus 1 is 2n for all n greater than equal to 2. Then we need to find A1 plus A2 plus dot all the way till A20. This is a good question. Just try solving it. Finding some questions. Yes, I have got some easy questions. They are all given in this again my tomato multiple choice questions practice. One very easy question. My angles of triangle are in AP. The ratio of the greatest, the smallest angle is 3:1. Then the smallest angle is, find the smallest angle. How to do this? Very easy. Just follow the basics as I had said. So let my angles be. Angles are basically A minus D. A plus D. My summation is there as E is 180 since my sum of the angles of the triangle is 180. So my A comes out to be 60. So my one angle is basically 60, which is my middle angle. And my ratio of greatest is to smallest angle. My greatest angle is going to be A plus D and my smallest angle is going to be A minus D. So my ratio is 3/1, that is 3:1. My A is 60. So basically 60 plus D by 60 minus D is 3/1. Then it comes out to be 60 plus D is equals to 180 minus 3D. So if we are going to calculate my D up here, so it is basically your 4D is equals to 120. So my D is basically 30. Therefore, my smallest angle is your 60 minus 30 is 30 or probably pi by 6. And one good question. But the question said that my question says in an AP I'm doing a mixture, okay, mixture of AP and GP problems. It's purely GP actually by technology wise and by theory wise also. There are more questions in AP and more critical questions can be made in AP than GP. So yeah, that's it. So in an AP, suppose that for m not equal to n, it is given me m not equal to n. Sum of first n m terms. Sum of first m terms is basically sum of first n terms. First n terms. Not equal to, sorry. So this is not equal to, it's basically it's given my ratio. My ratio of the sum of first n terms to the sum of first n terms is basically m square by n square. Is m square is to n square. And I'm given my 13th term of the AP. 13th term is 50. Then we need to find the 26th term. Is how much? Think about it for 2 minutes. So nice question again. So in the AP we are given Sum of first m terms. What would be my sum of first n terms? Sm would be basically your m by 2 into a plus m by 2 into 2a plus m minus 1 into d, and my sum of first n terms would be basically n by 2 into 2a plus n minus 1 into d. Now my ratio of this two is given to be m square by n square. This is your m square by n square. So basically it is going to be m by 2 into 2a plus m minus 1 into d by n by 2 into 2a plus n minus 1 into d. This is going to be your m square by n square. My 2 and 2 gets cancelled, and my 1m and 1n also gets cancelled. So m and n, so it's basically your m and n. So ultimately what we are left with, my m by n is 2a plus m minus 1 into d by 2a plus n minus 1 into d. These are my two summations. So again we are given, if the 13th term of the AP is 50. One more information what we are given is my 13th term is 50. So that is by a plus 12d is 50. This is one more information given. This is equation 2. I would like to simplify my equation 1. It would be making my things better. So if I simplify it, what I would be getting, so it is basically 2am plus md into n minus 1 is equals to 2an plus nd into m minus 1. So now if I open the bracket, so it is 2am plus mnd minus md equals to 2an plus mnd minus nd. So my mnd and mnd gets cancelled. So what am I left with? If I take all of my terms to the LHS, so here I am left with m minus n into 2a minus of m minus n into d is 0. I have just jumped out one step. I have taken 2a and to be common. So here my m minus n is going to be common. So m minus n into 2a minus d is 0. Now from here, since my product of two terms is 0, then either one must be 0. So this one, if my m minus n is 0, then it is m is equals to n, but we are given in the question that m is not equal to n, so this cannot be equal to 0. Hence my 2a minus d is equal to 0. That means my 2a is d. So from equation 1, so we have got a very vital information, which is probably the key to our solution 2. So from equation 1, or probably this was 2, I guess. Yep, from 2. From 2, what was I given? 13th term of the AP is 50. 13th term basically means my a plus 12d is 50. Now my 2a is d. So basically d is 2a. So ultimately what I'm getting is my 25a is 50 and my a is 2. So hence my d is 4. Therefore, what do we need? We need 26th term, which is my a plus 25d. That is basically a 2 plus 25 into 400. So my current answer to the question is 102. Is this clear? Normal manipulation, not a very tough one. There might be calculation error, but These questions are actually made for calculation errors. Since in MCQ, you probably have around 1.5 minutes for solving each question. So do keep it in mind while solving this type of questions that you don't make any calculation error. Just one question is there, which is probably you can remember it as a result right now. Just don't forget it. Write it up here. This is basically if my sum of first m terms is n, and my sum of first n terms is m, then my sum of first m plus n terms is basically minus of m plus n. Just remember it as result. This used to come as a question. Probably in both exams also this used to come as a question. But right now just remember the result, since if in exam you try to prove this, your 2 to 3 minutes will be wasted, which means probably one more easy question with this question is going to waste. So just remember this equation, this value, this result. Just keep it on your heart. Easy one, a little lengthy though. So yeah, there are some more questions. I am gonna wrap my sequence and series in my next lecture while doing my AP and then doing a plethora of different types of questions. So yeah, guys, that's it for today. All of you who are watching, for my next year, I am gonna bring up a course, a free course to mention it, a free course for preparation of ISI and CMI, which will be starting from 1st of June probably. Most probably, my tentative date is 1st of June. It will be continuing till my next year, where I will be solving or where I will be teaching each chapter from scratch to the most advanced level. That is my actual preparation. That would be basically not a crash course. That would be a foundation course for ISI and CMI. So that is going to be most probably starting from my June. So those who are targeting the examinations of ISI and CMI for the year 2026, they should start watching it from day one. It's going to be a super interesting one. I'm going to be sharing different types of question papers too. And all those who are watching it for this year, all the best to you guys. The exam is on 11th May. I have shared up some tips. We'll come up with some more shorts and tips in the upcoming few days till the exams. Do keep your mind cool, calm, soothing. This is an exam. Just treat it like an exam. Don't treat it like a mental pressure. So, yeah, that's it for today. All the best, guys. See you soon. Goodbye for now.